So let's start with a quick introduction. I think we have Thomas is gonna start
Yep.
with his part. Yep.
Yeah, thank you, Liara, and thanks, Eon, for helping us host this webinar. So my name is Tomas Talius, I lead the engineering team for BigQuery. Happy to be here and share what we've been working on and with all our community.
And Ofir, if you want to do a quick intro, and then we'll jump into the presentation.
Perfect. So, hi, my name is Ofir. First and foremost, I'm married to wonderful Julia, father to Roman Leah, cutest kids ever born. Other than that, previously, as Leo mentioned, we built a cloud network, which eventually became Amazon's AWS migration and disaster recovery solution. Migrated lots of machines, lots of companies into AWS, and we're responsible for the disaster recovery service for AWS as well. We also had an OEM agreement with Google. We got to know GCP early on, helping them migrate a lot of companies into GCP, so we're big fans since then. And today, I'm the co-founder of Eon. Eon is a company. In a nutshell, what we're doing is it's a cloud data infrastructure for data protection, governance, context, and access. And we're funded by some of the best investors in the world. And our mission is to make data across everything, all of your data. Your data is your moat. Make it usable and accessible for any of your needs, and especially be able to use an amazing tool like BigQuery to actually fulfill all of your dreams and utilize agentic AI to make everything come true.
Amazing. Yeah. So let's get into it and hear a little bit more about BigQuery specifically and what's new there. So Thomas, yeah, please take it away, and we'd love to hear from you.
Yeah, sounds good. Thank you, Liara. All right. Yeah, so let me talk a little bit about the trends that we're seeing in the industry and how that influences our roadmap. I think all of us will agree that we are now in the AI and agentic era, and the data systems are really no exception. We see analytics moving from systems for reporting toward systems which can do automated reasoning, and will help to automate the entire data lifecycle, build completely new data experiences, and really help you to imagine your business, right? And a lot of what we do and how we've been thinking about the product improvements are really based on this trend that we're observing. So if you look at our evolution over the last 15 years, we started with a solid serverless foundation. We innovated in streaming ingestion. We added machine learning, multi-cloud, support for BI, support for open analytics formats, unstructured data, Python, really making BigQuery as a full analytical platform for your needs, right? And the last few years, we've been innovating in AI assistants such as Gemini and BigQuery, AI co-processing, vector search, and also tools like conversational analytics, for example, to help all your business users. So we delivered over 300 features over the last 12 months alone, right? And we'll continue innovating on your behalf. So if you look at the scale of the service that we're running today, right, we are actually processing over 30 exabytes of data daily, right? We've seen massive growth in AI assistants, over 30 times year over year. We've seen massive growth in AI processing of unstructured data. Vector searches have been growing quite a bit, and as well as log analytics, right? So really, we're seeing growth in both classic, I would say, data warehousing, and also the new emerging areas such as AI and unstructured data. So I think one thing that we've been, as we've been looking at the trends with the emergence of agents and autonomous systems, we expect those agents to generate quite a bit more workload and questions that we'll try to answer autonomously on your behalf. So the price performance is more important than ever, right? We've been investing in enhanced vectorization modes, history-based optimizations, where we look at the queries that are running in your system and automatically optimize it. Short queries, because agents will want faster response times, as well as your classic dashboards. So a whole plethora of investments in price performance. And if you look at year over year with some of the standard industry benchmarks, the performance in BigQuery improved over 35%. The costs have actually reduced by 40%, right? And we'll continue innovating and enabling all those improvements on your behalf, so the system just keeps getting better, right? Now, with agents, we also expect the agentic workloads to be quite spiky, right? And the BigQuery serverless infrastructure that we have allows you to scale up and down almost instantly if you're using autoscaler, for example, right? Now, one more capability that we're introducing, we call it fluid scaling, right? Where you can instantly scale up and scale down, and you pay per second, really for the compute capacity in BigQuery that you use, right? So truly what we call area under the curve billing, so extremely efficient. So you should definitely check it out. And I think for people running BigQuery, that's one of the things that you want to look into. Now, I think if you're running BigQuery at scale, generally in the large organizations, you end up using constructs, what we call reservations, to manage capacity and assign compute capacity to your workloads or your teams, right? So we've been investing in quite a bit of manageability features, help you to introduce limits per reservation, limits per project, also control concurrency. So you can truly have more predictable resource boundary for your workloads, right? We're also creating ways of grouping those reservations. You can share those the compute capacity, such as slots, and also dynamically assign those reservations at the query submission time from what we call dynamic flexible assignments of reservations, right? So quite a bit of investment in workload management, right? And also thinking through the FinOps side, right? We've been investing also in diagnostics. So if you see BigQuery execution plans, we've been investing quite a bit there in the FinOps and the reporting through the GCP billing console. You can ask for cost attribution per project, per job, and we also have estimators to help you figure out the optimal capacity commitments, right? And then also through agents, you'll be able to ask and analyze also through the Google Cloud Assist, the right side panel, right? You'll be able to answer some of those FinOps questions as well, right? So we've been working on some of those capabilities, and they're coming all online. So now if you look at the AI side of BigQuery, right, actually we've been seeing success with quite a few customers. For example, Palo Alto Networks has been using BigQuery to process security events, and we've seen for about 40% cost reduction. PayPal, we've seen better performance and fresher data based on the AI personalization experiences that we built. Lowe's realized additional revenue based on their visual search that we built on BigQuery. And for example, Anthropic is using BigQuery and MCP to understand their telemetry and the product usage, right? So those customers are already successful today. So now on the AI side, we've been investing in BigQuery to make it possible for every data professional to use the tools that you're familiar with, like such as SQL, on the data that you already have in the data warehouse, right? So with BigQuery ML, you can create machine learning models, you can evaluate them, you can perform Gen AI-based inference on be it semi-structured or unstructured data, right? All with BigQuery, within BigQuery and using the scale that we're known for, right? And then you also have a choice of models, right? You can choose frontier models such as Gemini or Claude, and by the way, on Gemini, check out Google I/O, and we'll have a more exciting news to share there, right? And also you can choose Hugging Face models, for example, right? And all accessible within BigQuery. And then finally, if you look at some of the emerging RAG use cases, which are very common with agents, BigQuery supports billion row scale vector search, really pushing the limits there. So all those capabilities are useful for scenarios such as demand forecasting and sentiment analysis, classic ML tasks such as regression and classification, anomaly detection. There's quite a bit that you can actually do with machine learning and AI capabilities in BigQuery. So now the interesting trend that we're seeing in the industry is also emergence of foundation models, going beyond what you know as the kind of models which are based on text or multimodal, right? So in particular, for example, Times FM foundation model, which we have available in BigQuery, you can use it for time series forecasting and anomaly detection. Essentially, you don't need to go train anything, right? You simply give the existing time series to the model, to the AI forecast function for BigQuery, and will predict the future time series or will detect anomalies, right? So very easy to use, right? No training needed whatsoever, and you get very high quality results. The second model which we're introducing is tabular FM, coming shortly. So in this model, you can use foundation model for tasks such as classification or linear regression, right? And essentially give it label data, and you give it the new data that you want to go and score on, right? And the model will actually do the same classic machine learning tasks for you, right? So again, very easy to use and no training needed, right? So going a little bit beyond towards the new ways of processing data, right? We see emergence now of AI-based processing as well, right? So if you look at the classic data warehousing or database systems, the same SQL-based way has been there for almost 50 years or more. Now with AI and foundational models which are able to operate on text or on images or on videos or on speech, you actually have new ways of processing data. So we added those what we call managed AI functions. For example, you can go filter with AI if you can classify. For example, you can take a news article and classify it into categories, be it technology or sports. You can rank them based on, for example, sentiment, right? Or you can aggregate blogs or news articles, right? For those what we call managed AI functions, right? So this is truly a new way to use AI to actually process data and scale, right? And actually, we've been working on making it also feasible to process large quantities, right? And we're doing it via what we call optimized AI functions, right? So underneath the covers, if you use, for example, classification task with AI if or AI classify, we actually end up creating a small model, right, based on a sample of rows, which we use the large foundation model such as Gemini to go create sample data. And then we'll train that model on that sample and then use it to process large quantities of data, right? And we're seeing actually very comparable quality as if you were using the full foundation model, but you get about 200 times savings in reduction of tokens that you need and 150 times faster execution, right? So it's truly becoming possible to use AI to process data in new ways at scale. Now, we're not stopping there. We're also, for agents, introducing graph analytics in BigQuery. If you think about the businesses and entities and relationships that you have, you want to be able to model those and teach your data platform to natively understand it, right? So with graph analytics, you can define your graph in BigQuery. You define your nodes, you define your relationships, you map your tables into a graph so the data never moves anywhere, right? And then you can now use graph query language combined together with SQL and also combined with additional workloads such as vector search that we support, right? So truly powerful capability to define a graph and bring truly all your data together that you have, structured data, data in the lakes, or even unstructured data, right? So one more capability that we've been working on is measures, which we added in the graph, right? If you think about being able to ground agents and given the actual definitions of a business computations, such as, for example, revenue and similar metrics, right? If you put them deeper in the data platform, not only it becomes available for agents for high accuracy, but also becomes available for your other applications operating on top of data, be it your data pipelines, data science, and so on, right? So pretty powerful capability, and you can share those data definitions across all the ecosystem, be it AI or BI or anything else. So check this one out as well. Now, let's talk a little bit about the agents and the innovation that we've been doing there, right? When we think about agents, we want to make sure that you have flexibility to use the agents that we built, such as conversational analytics. You can use the APIs that we provide for those, but you can also go build agents using the MCP tools or open source frameworks, or even the APIs directly. So you have an entire spectrum of choices there. Right? So for the data developers, we provide free built-in agents. The data engineering agent available in BigQuery Studio, the most common developer console for BigQuery, allows you to create data form pipelines, modify them, operate them. The data science agent available in Collab Notebooks in BigQuery Studio allows you to generate notebooks which can transform data. You can train the models, you can featureize data, evaluate, and so on. So all your data science tasks. And finally, the BigQuery Assistant in the Google Cloud Console Assist on the right side panel. You can ask questions about SQL queries. You can ask to modify them, improve them, as well as additional administrative experiences in the workload management space that will be available in the BigQuery Assistant. Now, the capability that I'm actually most excited about that is coming to GA shortly is conversational analytics in BigQuery. And why? Because it allows you to go from creating dashboards, which are somewhat fixed, to actually giving access to your business users a much more flexible way to interact with data, where you at most you curate the data that agents should be working on, and then the business users can go and interact with them, right? So you end up creating an agent in BigQuery Studio. You give it tables or graphs to work on. You can publish it to your business users. So that's available in Data Studio, formerly known as Looker Studio, as well as Gemini Enterprise, where you can publish those agents through A2A protocol. And you can also embed it directly in your applications as well, right? So when we were designing conversational analytics in BigQuery, we wanted truly to enable all the business users to take full advantage of the scale and capabilities that BigQuery is known for, right? So for example, with graphs, we actually designed it together with conversational analytics and the graph analytics capability that I was mentioning to make sure that the agents could generate high accuracy graph query language code, use the measures that I was talking about, right? To truly produce the high quality and high accuracy agents, right? Now, for example, for machine learning, we also ended up co-designing it so that you can use the times FM foundation model to do forecasting so that business users can predict, for example, their business metrics, detect anomalies. And also in the future, we expect to enable those agents to automatically detect those changes and notify you, right? And then for unstructured data, we also enabled conversational analytics to go process the unstructured data right there in those conversational analytics agents. So you can imagine doing sentiment analysis, image processing, classification using those managed AI functions that I was mentioning, right? As well as, if there's embeddings available, we can take advantage automatically of those for some of the tasks such as disambiguating. For example, if you're looking for a specific customer, we'll do a semantic match over those to find customers with similar names when you're asking questions, for example, about your specific customer, perhaps revenue and sales and similar metrics, right? So we truly ended up co-designing the BigQuery engine and also the agent that's built on top of it to make sure that it works very well together end to end. So if you go towards building your own agents, right, we also provide you quite a bit of choice, right? So first, with an agent development kit from our friends in Gemini Enterprise Agent Platform team, we provide a BigQuery toolset. So you simply go enable it, and then you can find tables, you can find data sets, get their information, execute read queries, write queries, and some of the machine learning tasks, right? So it's actually very easy to go enable it to use, right? Now, if you're using MCP, GCP in general provides a remote MCP server for most of the APIs, and that those APIs have been growing over time. So for BigQuery, we were one of the first MCP servers available. Again, you get a way of listing data, executing queries, and you also get additional enterprise security through a model armor integration. So for example, you can defend your MCP endpoints against, for example, prompt injection attacks, right? And then finally, we provide a client-side based MCP toolbox for databases, which is also open source, supports a plethora of databases. It gives you additional configuration options if you, for example, want to take your database functions or store procedures, and you can expose them MCP tools for your agents as well, right? And we've seen quite a bit of growth, in particular for the BigQuery MCP server over the last few months, right? So now, as we were building our own agents, such as the data engineering agent, data science agent, we realized that we want to generally decompose them into tools, like MCP tools, and also the skills, right? So what we ended up doing, we recently released this Google Cloud Data Agent Kit, where we took the skills that we created for those agents, for the first-party agents that we created, and we also open source them, right? And we made them available. So those skills, you can use them in your favorite agentic ecosystem, be it Gemini CLI or Claude or Codex. And they can generate data pipelines for you. They can generate notebooks. They can operate those pipelines on your behalf. So it's actually very, very powerful capability. And you can integrate with other skills that you use for agents today. And we also taken those skills and also made them available in the most popular IDEs, such as VS Code and Cursor and others, where you can truly use for the developer experience, those skills, and get the end-to-end agentic development experience in your favorite IDE. Right, so check this one out as well. Now, once you create agents, actually, you want to understand how well those agents are doing. And there's a capability that we release called BigQuery Agent Analytics. We integrate with an agent development kit. We integrate with LangChain, where you can go and ingest the telemetry and logs into BigQuery, right? And then you can use all the power of BigQuery to go analyze it, right? Be it using tools such as conversational analytics and your favorite visualization or BI tools, right? And truly can start making sense where your agent is doing well, how are all the sessions are going, and what's the next step in improvement that you want to do, right? So check this one out as well. Now, like one more thing that I wanted to talk about is the also emergence of Apache Iceberg as the open analytics format, and we truly embraced it over the last few years through our investments. So we added support for Apache Iceberg REST catalog and additional table capabilities there. But really what we want to do is to take the best of the BigQuery metadata and storage systems and make it available for Iceberg as well, right? So you can actually store data in a GCS bucket. You have full control and portability if you'd like, but you get all the power and capabilities of BigQuery, and it's interoperable with other engines that you may choose to use, right? As well as we also integrated that with other SaaS services, for example, such as Salesforce, and we're working on a few others, and also cross-cloud with other hyperscalers. So in particular on cross-cloud, we've been actually seeing customers, in some cases, it's kind of been complicated to go and actually get the data and move it, potentially have to ingest it. And we wanted to simplify this quite a bit if your data is in Iceberg format, right? So we developed what we call cross-cloud lakehouse, which is working together with a cross-cloud interconnect, say between GCP and AWS. We're adding additional caching capabilities over in GCP side. So it's actually becoming practical to process data across clouds at scale, even if the data itself actually lives on, for example, AWS, and Azure is also coming soon, right? So we truly want to bring all the data that you have in your enterprise together, right? Be it in BigQuery managed storage or in Apache Iceberg, right? And then you can also put, for example, a graph layer on top of it, right? And then have high quality and accurate agents as you go build your systems and you operate. So with this, that was the quick tour from what's new in BigQuery, and I'll pass it on to Ofir to share his thoughts as well.
Thank you very much, and it was really insightful. And as I mentioned before, I'm CEO of Eon, and we're adding a new layer of ingestion and data ingestion and storage for the purpose of data protection, governance, context, and access. And we're big fans of BigQuery. We're actually users and customers of that, and we think that, especially with new developments, especially around AI and agentic AI in particular, you can do magic with platforms and especially like BigQuery. I want to speak about a problem statement that a few of us encounter, especially as with data teams. And let's say that you're a data team inside organization, and you're tasked by your CTO, your CEO, your board, saying data is the new moat, is more important than ever, especially that with AI, with BigQuery and agentic AI, you can do magic with that. You can actually really do things you couldn't before. Data is going to be moat no matter which compute engine is going to win. So let's make the use of that. Let's use BigQuery for that. Only problem is data is fragmented across the organization. Ideally, of course, it's already in our data lakehouse or in Iceberg format, which is amazing. But think of a large company, large enterprise, where they have teams in San Francisco, and New York, and Madrid, and Japan, and Amsterdam. And each team, each business unit owner is responsible for a different set of data sources, like data warehouses, object storage, virtual machines, file shares, everything. This data is siloed, and most of the time, most of the organization don't even know what data it has and what data it accrued throughout the years. Now, as a data team, you need to find out where this data is, and then when you even get to this data, try to get to the business unit owner and say, what is even in the data? Let's say that you got the attention of those business unit owners to share the data with you. That's great, but now you have a problem that You need to understand, do I have personally identifiable information there, healthcare information, some other type of sensitive data? Who is even eligible to access this data? I'm required to audit everyone and everything that is being done with this data. How can I do that if I need to pass it to somewhere else? How is it governed at all? Let's say we got through all of those. Amazing. Now we need to establish an engineering effort, which is not trivial, to create some sort of an ETL on ELT to extract the data, let's say from your Postgres, from your MySQL, from your S3, it doesn't matter. Extract the data, find a way to transfer it throughout the organization, so involve security, make an operational effort to maintain this continuously and make sure you don't cause any downtime to your production environment, which is where you get your data from. And in relation to what Thomas just mentioned, it could sometimes be very expensive because you extract the data, which is expensive. You need to transfer it, and then you need to transfer it either between clouds. Let's say it was in AWS, and you need to now move it to GCP, or between regions if you want it in the same region. That's very cost intensive as well. We at Eon strive to help and solve that, and try to access your data, extract it, and give and understand everything that's going in there, build a semantic layer, a content graph, and classify it so that we can understand exactly what you can understand exactly what you have in your data, bring it into one centralized Iceberg catalog, so this can be immediately accessible by BigQuery. Your sources can be from everything, like virtual machines, databases, lore archive, object storage, and so on and so forth. And we're able to help you build that without any use of executables, of appliances, of all type of networking, just using this new thing called the cloud, which is enabling you to do everything to a really great infrastructure. In short, our joint value to the customers are our ability to map all of the data across the organization within a few clicks in multiple clouds, multiple business units, multiple hyperscalers, get it into GCP seamlessly and in a very efficient manner, and be able to then immediately consume it and use all the magic that BigQuery can give you on all of your data throughout the organization. That's it. Lior, take it to the live Q&A.
Yeah, thank you, Ofir, and thank you, Thomas. Really great discussion. I think, like we saw from a lot of the chat, I know you guys were busy presenting. There was a lot of interest around, specifically Thomas. I mean, you made a lot of impressive announcements on what the team has been working on, especially enabling AI capabilities and other workflows on top of BigQuery. And also Ofir, just on the idea of, the data fabric concept and unifying data across geographic and even cloud boundaries. So I think there's a lot of interest, from this audience. We have a bunch of questions, and we've also had some people voting on the questions. So we will take the most voted on questions and probably discuss them. And if it's okay with you, Thomas, we'll start on a couple of the BigQuery capabilities.
Yeah, that sounds good. Yeah.
Okay, great. So a lot of announcements. One of them that you referred to was about fluid scaling. So a few people are asking, how do I enable fluid scaling? Is there anything special that needs to be done? We heard that is now GA.
Yeah, it's coming shortly, actually, in the GCP console, in the BigQuery workload management pages, right? And then you can turn it on at your reservation or admin project level. Okay. So yeah, stay tuned. Like, watch our release notes. Yeah, and we'll be there shortly. Yeah.
Okay, so look out for that.
Yeah.
Another couple of questions that we had, Thomas, were around the AI function. So I know, at least for me, seeing that is really compelling. Like, to be able to go in a SQL query, AI if, and go. So I think some were asking about the behind the scenes on that. So scalability, anything that they have to watch out for, like if I'm doing it on something that has millions or billions of rows, any type of things they should be careful of when using?
Yeah, so there's a few things. I think we actually spent quite a bit on time to optimizing in general AI inference in BigQuery. For example, we actually understand quotas that you may, for example, have right on the Gemini Enterprise Agent platform, formerly known as Vertex AI. Right, so we'll actually figure out the optimal kind of degree of parallelism, right? If it is provision throughput that you have, we can use that, right? And we'll also run a lower inference priority when you interactive workloads so that we don't interfere, for example, with your kind of potentially customer-facing interactive applications. We actually, over the last few years, done quite a bit to actually scale and make it robust and reliable and so on, right? And then it's the same infrastructure is being used under the covers for AI.if and AI classify and all those functions, right? Now, there is also a question that our customers often ask is, well, how do you know that this is not going to be prohibitively expensive? So actually, one of the recent functions that we're adding is called AI count tokens, where you can actually estimate, like before you run a job, right? How many tokens do we expect that this job will consume, right? And then finally, the AI optimized mode that I was talking about for AI if and AI classify in particular, right? That is actually designed to reduce the token usage and improve the speed, right? Because you really want to be able to process large quantities of data, right? If you're trying to classify, for example, or filter something, right? So like what we do internally, we actually assume that you have embeddings pre-generated. So you should do that. And then we will automatically train a model before running a query on a sample of rows, right? We'll invoke the real large the Gemini model, right, to actually get answers and essentially get the labels to train a small model running over those embeddings, right? And then we'll take that model and we'll run it over large quantities of rows, right? And there's actually even a paper that we're putting out for one of the database conferences. Actually, if you look at the quality of the results that you get using those techniques, they're actually comparable to running and basically doing a brute force AI inference over a large number of rows. Yeah.
Okay, so there's some specialized thought.
There is some special secret sauce we've been working on to make it this really scalable and efficient. Yes, that's a quick summary.
Well, that's really interesting to hear. And the other, I mean, I think we had a couple of questions on the scaling side of it from people like Alexander, but then we had another, I'd say half of the coin on these questions about the AI SQL functions, which is about under the hood, what actual models are being used. So I think in general, to combine a few of them, the idea is, which models are being used. Can I choose or uptrain or use a pre-trained model if I want to sub it out? And also just like you kind of mentioned, understanding, as a user, as an enterprise user of the solution, is my data in the query, being used for training or anything like that? So those types of questions people are asking under the hood, what's happening.
Yeah. Fair enough. So I would say in terms of model choice for the generic kind of the most common AI.generate function that we have, and you have the Gemini models and Claude models that you can go use, right? Mm-hmm. Or also the Hugging Face models, right? Now, for the AI functions in particular, because we also designed and optimized them to work well end to end, right? And we call them managed AI functions. Those work with Gemini models.
Okay.
Right. And then finally, in terms of data and model training, so we never use customer data to train any models, right, at Google, right? So anything that you have in GCP, right, it's your data, so we'll never go train on it, right? And we have very strict access controls, like to all the logs and anything, right? So we actually we go to great lengths to make sure that you're confident in the systems that we run. Yeah.
Okay. No, that's really great to understand. And I think moving beyond this, there was another question, a little bit less moving away from the AI functions area, specifically about range joins. Okay, so this is a question from Jiri, who asked, are there any plans to improve range join performance in BQ, and citing it as a big cost factor when they join multiple historized tables coming from different data sources? So I don't know if this is something.
Yeah, maybe this is something that we can connect, I think, offline. But I would say in general, we are always innovating on price performance, right? And if you look at some of the numbers that I quoted there on some of the industry benchmarks, you see those. And we also because the analytic workloads tend to be somewhat repeatable, right? We invested into techniques like history-based optimization. So if you run the query or the job pipeline multiple times, like we'll actually optimize it over time. We're also investing in the second version of it, where we actually look at the overlapping kind of shared parts of the queries and actually also use that data to actually improve the query execution, right? So expect to see a continuous, say, stream of improvements there in general. But I think on that specific issue, maybe we can simply connect offline. We'll figure out how we can help you.
Absolutely. Okay, and so now just one more on the AI topic, on the AI functions topic that we see, which is, hold on, let's get it over here. This is a question from, oh, hold on, I'm looking for this right now. Oh, it's asking about the concept of memory. So this is from Xiong. For the AI functions, how is memory handled? So is there a concept of, I guess sometime a kind of persistence or model memory across the org, or how does that work?
Yeah, so I would say on the AI functions, where I would say lower level building block, right? Where we don't have memory themselves, right? Now, generally memory is associated with agents, right? So for example, the conversational analytics agent that I was talking about, actually, we are actually adding memory support there, or in Gemini Enterprise, right? If you go chat with data or build your own agents, there's also concept of memory. And then finally, if you're building your own agent through Gemini Enterprise agent platform, there is capabilities such as memory bank, right? Where you have control of what is a user, what is a session, what is a conversation. You have this notion of memory that you can go create, right?
Okay. No, that's really, really helpful. And I think now we have another question. This one's actually for Ofir. So this is talking about, and I think both of you guys talked about, so both Thomas and Ofir, you talked about the concept of cross-cloud or being able to query data across different sources. So they're saying we have most of our databases in AWS, but our teams love to use BigQuery where they can. So from what you described, can Eon help with that, Ofir?
Okay, so this is actually a great question, and it's something that we see time and time again, whether it's in a different cloud or in multiple regions that you want to get to one region. And there are problems both with ingesting the data, but also transferring that both from an operational perspective, but also from a cost perspective, which will be very significant, especially egress fees around between different clouds. What Eon does is that we extract the data into Parquet format and put it in an Iceberg catalog in the source cloud. And then we use what we developed and we heavily invested in, which is context-aware, infrastructure-aware deduplication and compression, specifically built for Parquet format and Iceberg in specific, allowing us to drastically reduce the amount of data that you need to move between clouds. So it both reduces latency, improves performance, and drastically reduces the cost. And of course, we use caching mechanism on each side, but the duplication is being done at the source, also compression, so you don't need to send too much data relatively to the other cloud, thus making it actually useful and actually usable for a BigQuery without significant amount of extra layer of operational complexity and definitely cost.
Mm-hmm. Yeah, and I think Ofir, that's a really great point. We had another question as well from Anvesh, where we're kind of asking about different ways or being able to be more performant in pulling data across clouds. And it sounds like what you're describing is kind of using more novel approach to be able to still leverage the data query without needing to move everything right from the original source.
It's definitely, it's very important that we're trying to do things that you don't want to hurt your production environment in any way. You don't want to incur more cost. You don't want to incur more networking complexities or quality of service. The cloud enable us to do amazing things around that. So not needing all types of proxies and appliances and installing sensors and stuff like that. So we're able to do very efficient, very fast ingestion of the data. And then again, as we continuously deduplicate and compress it, we're drastically improving both latency, reducing latency, improving performance, and making it much, much more cost effective to actually make it useful.
Okay, that's really, really helpful. And I think there were a couple of questions as well, just similar in a similar range, just talking about unifying data across clouds. So thank you for those. And I know this was a really interesting topic for us. And in that note, Thomas, I think there were a couple of questions asking about when we think about the multi-cloud capabilities or querying across regions, across different projects, things like that, how do BigQuery's decentralized governance capabilities work? So if we think about it, there was a question, I'm kind of consolidating a few in the interest of time, questions about RBAC or using governance features. How do those apply, if they do, when we're thinking about like Lakehouse or cross region capabilities, et cetera?
Yeah. So we work with, for example, when we federate to our clouds or our SaaS providers, generally all those REST catalogs have a notion of a service accounts or service principals, and you essentially provision a service account for BigQuery's Iceberg kind of system to go use and connect to those systems, right? So that's how you control permissions of what users in BigQuery can access, right? And then you also use IAM permissions over in BigQuery side to basically grant access to those resources, right? So now if you operate solely within, say, BigQuery ecosystem or GCP ecosystem, we have a capability called global queries in preview as well, where you can go join across the different regions, and we'll actually push down, as kind of a part of a query which is relevant to that region, and we'll move the data and we'll process it, right? In those cases, we just run everything as those end user credentials, because everything is running within a kind of BigQuery system. So, and I think over time also, I would say those Iceberg systems will evolve to support end user credentials as well, right? Because ideally you want to have data security managed in a single place, but I think as of now, you still need to use service accounts.
Okay, that's really helpful. And I think another one which is similar. So I know there were a couple of questions from an agentic standpoint about RBAC. If there's any plans to apply like an RBAC approach for, I guess, agentic workflows on top of BigQuery.
Yeah, definitely. Like, for example, the agents that I was talking about in, say, conversational analytics case, right? When you have a notion of agent creator, somebody who kind of curates it, and you say, configure agent to use certain tables or data sets, and then some system instructions, right? So with permissions, who can control that agent, right? And then there is also the notion on the role of an agent user, right? And those typically would be a business user community, right? Where you, again, grant them permissions to go use that agent, right? And you publish it to different sources. Now, if you're building your own agent, of course, through agent platform from Google, then there's, again, permissions to those specific resources, and then within your agents, you can also authenticate the conversations and so on, right? So kind of depending, I would say, which level you come in, you have different controls, and either more kind of pre-built things or more flexibility, but you have to kind of build your own agent. But yeah, pretty good set of capabilities in the platform.
Okay, well, thank you for that. And last question is around, I guess they're giving specifically, this is a question from Peter Rahani, giving specifically an example of conversational analytics. But I guess the question is there a capability or any type of way to implement a review method in some of these, within BigQuery? That's the question, if there's the ability, because sometimes, right, having issues with accuracy on more complex queries, to implement a kind of human in the loop for our workflow that's using conversational AI.
We have actually a few capabilities where one is actually we show you the actual SQL queries that we generated, right? So you get to actually inspect and review it, right? There's also a notion of what we call verified queries or golden queries in the agent configuration. You can actually say, like, for those are the queries and those are kind of the questions where you can actually configure it. Right now, over time, I think we want to go and automate that more and more as we go index all the tables in systems such as Knowledge Catalog, formerly known as Dataplex, right? We want to simplify the task of working with data as much as possible, but we also want to give you enough control if you want to kind of have like very tailored, high quality experience, right?
Okay.
Yeah,
Oh,
I think I'm happy also to connect offline us on the conversational analytics as well. I think Leon and Eon team can help me connect with attendees, and I'm more than happy to follow up.
absolutely. And I think it's a good point when we think about, there's a couple of questions in there, like we talked about, joins previously, and a couple of questions on slot reservations, things like that. So different types of specific performance questions. We could definitely, connect the BigQuery team.
Yeah, sounds
with those
good.
that ask those afterward.
Yeah, I would love to learn more.
Okay, that's great. And then last question that we can ask. There was a lot of interest in BigQuery Graph capabilities. Anything that you want to give in the way of an announcement on when to look out for that coming out?
So that is actually all available in preview, like graphs and measures and everything, and like conversational analytics also works with it along. And yeah, we're working on GAing it, but yeah, you can definitely try it out today. Yeah.
Okay, so already available in preview.
Already available, yes. That's
look out for that.
Yeah, pretty excited.
Absolutely.
Yeah.
All right. Well, I want to say, I think this was a really great discussion. I appreciate, Thomas, all the open kind of conversation of what you guys have been working on the BigQuery team. I think, obviously we all know about BigQuery being an amazing analytics platform, but adding all of this kind of into the ecosystem just without the need to go anywhere else, right, in order to get this functionality. Really interesting stuff. And from Ofir, the ability to bring more data into BigQuery to leverage all of this, also interesting. So really appreciate that, and thank you to our audience. A lot of questions. We only got to get through about half of them, but we will be reaching out for all those specific, BigQuery or Eon or data management questions. We'll also make sure to follow up with you. And to those that asked about our agenda, so Julia from Eon has just shared the agenda for the day in the chat. But this was our session. Really appreciate everybody. And stay tuned for our next session, where we're going to have Alicia, who's a developer advocate with Google Cloud, and we're going to talk about practical workflows on BigQuery. So yeah, thank you very much, Ofir and Thomas.
Thank you for having me, and thanks Eon for helping co-host. Yeah, and thanks everyone joining. Appreciate it.
Thank you.
All right.
Have a great day. Bye, everybody.
Bye.